And homework number 1 is nth roots and simplifying radicals. All right, so this top section, we are giving all the possible roots to the radicals below. So the directions are important because if it says give all possible roots, you would include the negative ones if you've gotten even roots. All right, so this, like the square root of 225, for instance, you've got a positive value under an even root. So you have plus or minus, and then you have 2 different real answers, the positive version or the negative version. And the square root of 225 is something that comes out evenly. That is 15. All right, so the square root of 225, the principal root, like we talked about, is 15. But if we're saying to state all the possibilities, that would include a negative 15 as well, because negative 15 times negative 15 is also 225. All right, in this next section, I'm going to do one that's just numbers and then one that has variables too. So let's do number 5. 5 times the square root of 150. So simplifying the radicals, what you want to do is take that number that's underneath the radical and figure out what its biggest possible perfect square is. So I want to show you a little trick that I like to do is just kind of going through the list, unless you recognize it immediately, of course, you don't have to do this. But you can go through the list and see, like, is it divisible by 4? No. The next one is 9. No. The next one is 16. No. Next is 25. And there you go. So it's divisible evenly by 25. It comes out to be 25 times 6. If this number still has a perfect square factor, you didn't go far enough. Okay, so the trick that I'm showing you, you don't just automatically go with the first one that you find. You have to make sure that the remainder doesn't have any perfect square factors, and 6 doesn't. It's a multiple of 2 and 3, and neither one of those are perfect squares. So 150 breaks down into 25 times 6. So we write the 5, and then we write the square root of 25, the square root of 6. Okay, so let's write everything out. So here's the 5 times, and then we're going to take care of this. Comes out to be 5, and then the square root of 6 doesn't break down at all. So just simplifying that up, we're going to multiply the 5 times 5. Gives us 25, and then there's a root 6 left over underneath the radical. All right, same rules are going to apply no matter what the index is. You do the same thing for cube roots, same thing for fourth roots. Just the little trick I did, you'd be dividing out the common cube roots for this one, or dividing out the common fourth roots for these ones. All right, let's look at one that has some variables in it. Let's take a look at number 11. So we've got the 3 is out front, and then we're going to take all of these things and break them down into their smallest pieces. So we're going to do the same thing I just did with the 252. So divide it by 4. So this does come out evenly. However, 63 is still divisible by a perfect square. Okay, it's still divisible by a 9. So I'm going to start by breaking it down this way. I'm going to break it down into 4, 63, and then we'll talk about the k to the 5th in just a minute. All right, so the 63, you can break that down into 9 times 7, and 9 is a perfect square. All right, so if I take this 9 and multiply by the 4, that means I've got 36. Okay, so 36, and then times 7. So 7 is going to be part of the unsimplified. And you can double check here. Like 252 divided by 36 ends up giving us 7. Or we could have kept going and doing this, and we would eventually found the 36. So 252 is 36 times 7. Remember, when we're talking about exponents, if my index is 2, that means that my exponents have to be multiples of 2. So what I'm looking at is, out of these 5 powers, I'm looking for the biggest multiple of 2. And that would be k to the 4th. Okay, so I use that because 4 is a multiple of 2, and then that leaves me with 1k. All right, so 36 times 7 is 252. K to the 4th times k is k to the 5th. This part I'm able to simplify. This part I am not. All right, so 3 stays right here, times. Square root of 36 comes out to be 6. Square root of k to the 4th comes out to be k squared. Remember our little division trick, and then these are my leftovers. So I'm going to simplify that just one more time. 3 times 6 is 18. There's a k squared on the outside, and then there's a 7k left underneath.